All right, hi everyone. I'm gonna be going over skill practice 42. Um, so yeah, I do speak a little bit slow, so keep in mind for that. And so you can speed up the video to your liking. All right, yeah. So without further ado, let's get into it. So we're first presented with this table, and we have to fill out all these we have to fill in the missing blanks in the table. So the way we fill in the missing blanks is that all these rates are proportional to each other. So for example, the, let's just fill out, let's focus on moles of H2SO4. I'm gonna calculate it first though. All right. So basically what we can do is we can subtract the moles of I from 0.0021 from zero, and then that change, we have to multiply it by 3 because there's 3 moles of HSO4, and then we have to add it to 0. So it's always subtract, um, multiply by mole amount, yeah, multiply by mole amount, and then add or subtract depending if it's a product or reactant. So it's always, yeah, let me write this out. Subtract time. Two is multiply by mole amount. And three is add or subtract. Subtract if product or reactant. Product or reactant. All right, so 0.0021 minus 0 is also 0.0021. And then we multiply it by 3, which is 0.0063. And just add it to HSO4. Um, here back. All right, so let's do the same thing for the next one for the interval of 400 for HSO4. Now we can't just simply add 0.0063 again to it because it's always a curve. So it's the rates are always changing. So it has to be with the most recent. So we have to subtract 0.0032 from 0.0021. Hold on. All right, yeah. So you take 0.0032, subtract it from 0.0021, and then that will give you 0.011. And then you have to multiply by 3 again, right? So because it's the mole amounts. So that'll give you 0.0033, right? Here's the work. Yeah, 0.0021 minus 0.0032 minus 0.0021. You multiply by 3. I'll give you 0.0033, and then you just add that to 0.0063. And then you'll get 0.0096. All right, and then you just do the same thing for the last one. So 0.0039 subtracted by 0.0032. You get 0 point something 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 7 times 10 to the minus 4. And then you multiply that by 3, you get 0.0021. And then you add that to 0.0096. And then you get a final answer of 0.0117. All right, cool. We did actually is so four. Let's move on to IO3. Now, for IO3, since it is a reactant, we have to you just subtract it. All right, so let's just do the moles for I for this one because look, moles of I, the coefficient is 1, and IO3, the coefficient is also 1, so it'll be relatively the same. So for moles of iodine, right, 0.0021 minus 0, which is going to give you, right, 0.0021. You don't have to multiply or subtract or divide it by anything because the molar amount is 1. So you just take, we have 0.0105 subtracted by 0.0021, right? Subtracted by, and then you'll get 0.0084. All right. I'll do the same thing for the other two. 0.0032, right? Minus 0.0021. You get 0.011. 0.0011. Don't multiply divided by anything. And then you just take you have 0.0084 subtracted by 0.0011. And you get 0.0073. All right, and then it's the last one. The last interval, 0.0039 minus 0.0032. And then you take that number, just 7 times 10 to the minus 4. Wait, hold on. My thing is mirrored. All right, here you go. You just take it, and you just divide it or subtract it from 0.0073. You're gonna get 0.0066. Okay. For moles of HSO3, right? It's the same thing. But for this time, let's use the moles of IO3. Or actually, yeah, oh yeah, let's just keep on still using the moles of iodine, right? Because it's the same thing, but the mole amount is 3, so you have to multiply by 3, and then you have to subtract it. So, yeah. So look at the mole amounts for for the first interval, 0.0021 minus 0. That'll still give you 0.0021. Multiply that by 3, 0.0063. You take 0.0357 and subtract it from that. 0.0294. All right, then to the next one. 0.0032. Subtract that by 0.0021. Multiply by 3. You know the deal. And then subtract that from 0.0294. Yeah, 261. All right, and the last one, right? 0.0039 minus 0.0032. Subtract that times 3. You get this times 3. And you take that, subtract it from 2.61, 0.0261, 0.024. Let me get tissue real quick. All right, we're back. So we filled out the table. Let's move on to number 1 now. Oh wait, no, we just did number 1. All right, number 2. Calculate the average rate of formation of iodine during each of the following intervals of time. Your units should be in molars per second. So from 0 to 200, right? We have you have to look at 0 to 200 right here. So you have to look through these two numbers, 0.0021 and 0. And so to calculate the rate of formation, it's always the change. It's always a change in it's always like final minus initial. So it's always 200 minus 0. So the interval of 200 minus 0. So the interval for 200 minus is 0.0021 and 0. So the formula is as follows. All right, so you have 0.0021. You write that first because it's on the interval from 0 to 200. 200 minus 0. You always do the final minus the initial. You divide this by the volume, which is 0.45. Right? So you subtract that by the interval of 0, which is 0, and then 0.45 again. right? And you divide this whole thing, whole thing by 200 minus 0, right? Then you should get, after properly calculating it, divided by, here, I'll just do it for you guys. This will give you 0.0046, then minus 0 all over 200, which is just 0.0046 divided by 200, which gave me 2.3 times 10 to the minus 5 m over s. All right, let's go. All right, between the intervals from 200 to 400 seconds, it's the same thing, right? The interval for 200 to 400 seconds, that was going to be 0.0032 and 0.0021. Okay, so you have 0.0032 divided by 0.45, right, by the volume. This is because 0.0032 is the molarity amount. It's moles, right? It's moles, and you divide it by volume, which is liters. Moles over liters is molarity. That's why it needs to be molarity. And then this denominator part is 200 minus 0. That's a second interval. That's in seconds. That's why it's always m over s. So minus 0.0021 divided by 0.45. Right? Keeping these consistent. Divide all this by the interval from 400 to 200. Oops. Yeah. There you go. You should get 1.22 times 10 to minus 5 m over s. All right, for C, 400, 600. 600 is 0.0039. 400 is 0.0032. So with that information, let's just plug it in. Plug and chug. 0.0039 minus 0.45 minus 0.0032 over 0.45. Divide all this by the interval, which is 600 to 400. You should get 7.78 times 10 to minus 5 minus 6 over s. If you guys don't know how to get these numbers, feel free to message me. I'll be more than happy to help. All right, so if the rate of disappearance for HSO3 was 0.0045, calculate the rate of appearance for I. All right, and so the way I approach this problem is, you know that the rate of formation in this and anything like that, this whole like rate stuff, it's all proportional to mole ratios, right? So the mole ratio for HSO3 and iodine, right? HSO3 is 3 to 1, right? By the coefficients, 3 to 1 for HSO3 and iodine. Now, so the rate of disappearance is 0.0045, right? The rate of appearance, right? We don't know that. But look, 3 to 1 equals 0.0045 over x. You can just cross multiply here, right? With 3x equals 0.0045 divided by 3 by both sides, you can get 0.0015 molars per second. All right. Yeah, that's the end of skill practice 22. Let me know if you have any questions, and happy studying, guys.